Alright, solving this problem, we'll start out with I equals 50.175 squared, so I equals 1.53. And we'll do mv plus the integral of f dt equals mv2. Now this starts from rest, so that's 0. Now force times time, we have two forces. We have the force here, we also have the force of friction acting on the bottom. So 150 is the force up there, times time. That's causing rotation that way, so we'll do, I know because in the x direction, so let's do that way. Force times distance. Minus 3, which is the time, times the force of friction. And that equals the mass times velocity, 2. Now we can put into here v equals omega r, which equals 0.3, this radius all the way out, times omega, and put that into right there. So now we have 450 minus 3 force of friction equals 50 times 0.3 omega. So we have 450 minus 3 force of friction equals 15 omega. Now let's deal with, that's the linear momentum. Now let's deal with the rotation. So the integral of the moment about g, the center of gravity, dt is equal to I omega. Now the moment is caused by the force of friction and p, because they both have a distance from g. So 150 times 0.2, the distance, times the time, 3 seconds, plus the force of friction times the distance, 0.3, times the time, 3, is equal to 1.53 omega. Solving for F, force of friction, we get 1.7 omega minus 100. Now we'll put this into there, and we get 450 minus 3 times 1.7 omega minus 100 equals 15 omega. Solving for omega, and we get omega equals 37.3 radians per second.